What is differentiation? Differentiation is a fundamental concept in calculus that measures how something changes as the input change. It represents the instantaneous rate of change of a function with respect to one of its variables. The diagram shows how differentiation transforms a function into a derivative, and that derivative represents the rate of change. From the definition of differentiation, we get h as a small change, and the limit is the instantaneous rate of change. Think of it as like this. If you're driving a car and the position of your car is like the original function, while your speedometer reading at any moment is like the derivative, telling you exactly how fast you're going. These are the three notation in differentiation and the common differentiation rules. The constant, the power rule. The quotient rule and the product rule is used when differentiating product or quotient of a function. For chain rule is used for composite function that has one function inside of the other. These four are the common functions that you would find in differentiation, which is the exponential function, the logarithmic function, the polynomial functions, and the trigonometric function. For implications of differentiation is finding the maximum and minimum values, mean value theorem, determining increasing and decreasing functions, related rates, and Rolle's theorem.
For question 2, define us to find the dy dx for the following function. For question A, first of all, we will use product rule. So after that, we will let u equal to 4x squared, and then we will let y equal to cos 5x minus 2. After that, we will need to find the u prime, which is d over dx in bracket 4x squared. So differentiate that, you will have 2 times 4 to the power of x, 2 minus 1, which you will get at x. After that, we will need to find v prime, so it will be d over dx in bracket cos 5x minus 2. After that, we will differentiate it, so it will become negative sin 5x minus 2 times with 1 times 5 to the power of 1 times 5x to the power 1 minus 1. So we will get negative sin 5x minus 2 multiplied with 5. So the product of that, we will get negative times 5 sin 5x minus 2. So find the dy dx for this function. So we have dy dx equals to u prime v plus uv prime. So it will be at x multiplied with cos 5x minus 2 plus with 4x squared multiply with negative 5 sin 5x minus 2. Multiply or expand the equation, you will get at x cos 5x minus 2 minus 20x squared sin 5x minus 2. So that's the final answer for question A. For question B, first of all, we will need to use quotient rule. So quotient rule is dy dx equal to u prime v minus uv prime over v square. So we have to find u and v first. So let u equal to 3x plus 1 and v equal to sin 2x. Now we have to find u prime, which is d over dx 3x plus 1, which we will get 1 times 3x to the power of 1 minus 1 plus 0 times 1, which we will get 3x, 3 only. For v prime, we will have d over dx in bracket sin 2x. So we will differentiate that, and we will get cos 2x multiply with 1 times 2x power of 1 minus 1, which we will get cos 2x multiplied with 2. So multiply the both of it and we will get 2 cos 2x. So to find dy dx, we will use the formula from just now, which is u prime v minus uv prime over v square. Substitute the value, we will get 3 multiply sine 2x minus 3x plus 1 multiply with 2 cos 2x over sine 2x square, in bracket sine 2x square. So I multiply the equation, so you will get dy dx equal to 3 sine 2x minus 2 multiply with 3x plus 1 and cos 2x over sine square in bracket 2x. So that's the final answer for B.
Hi, I am Natasha from AS1202A and I will be explaining question 3, which involves implicit differentiation. Step 1 is to differentiate each terms with respect to x. For the first term, product rule will be applied. This means we have to let u equals to y and v equals to ln 2x. Then find u prime and v prime. Once you get the values, just substitute in the formula. The answer will be y over x plus ln 2x times dy dx. The same rule also applies in 6y in the third term. Now we repeat the same steps in the previous one and the answer will be 6 times dy dx. Now combine all the values that we get into one equation. Step 2 is to rearrange dy dx on the left hand side and the others on the right hand side. Once we already move all the terms with dy dx on the left hand side and all the terms without dy dx on the right hand side, we can move on to step number 3, which is to factorize dy dx and to simplify. Remember, our goal is to find dy dx, therefore factorize dy dx from each term. Now make dy dx the subject and there you have your final answer, which is e to the power of 5x plus 3 times 5 minus y over x, the whole thing divided with ln 2x minus 6 second square 6y. That's all from me. Bye!
Hi everyone, my name is Nur Shafika Shahira and I am from AS1202A. So today I'm going to teach you guys how to do question 4, which is use linear approximation to estimate the value of cube root 63.98 minus 2 over square root of 63.98, correct to the 3 decimal places. For this question, you guys will have 5 steps to do. For step 1, you guys need to determine the fx, x, and x0 from the question. For this question, the fx will be x in the power of 1 over 3 minus 2 over square root of x. For x, it's 63.98 and x0 is 64, since it is the closest value to 63.98. For step 2, you guys gonna use the formula given and substitute the value that you have found in question in step 1. So step 3, you guys need to find the f prime x from fx. So the f prime x will be 1 over 3 x in the power of negative 2 over 3 plus x in the power of negative 3 over 2. For step 4, by using x0 equals to 64, we need to find the f64 and f prime 64. For the answer for f64, it should be 3.75, while f prime 64, the answer should be 35 over 1536. For step 5, use the formula given above to substitute the value to find the final answer. And the final answer should be 3.750. Thank you, everyone.